Today I'm going to be modifying a three-way point on my model railway in N-gauge. How hard can that be? So a few weeks ago I installed this three-way point. I was quite pleased with myself at the time, but I now realise I've made several mistakes. The first is when I glued it down, I put glue along the full length of the point, and so that meant there was glue underneath the two throw bars here and the switch blades. They still seem to move quite freely, but I think they do still drag a little bit on the cork. But the bigger mistake I made was not to add extra wiring. There are several points on this three-way point where connectivity to the track is dependent upon a good connection between the switchblade and the stock rail. But that's not always the case, especially if the point's been painted. And over time, deposits and dirt might build up that would create a bad connection between the switchblade and the stock rail. This particular three-way point is going to be concealed from view, and it'll be very hard to service once I've built the scenery that goes above it. To see more about what the problem is, perhaps we need to take a look at a new three-way point that I haven't installed yet. Okay, so here I've got a new Peco Streamline three-way point. This is for N-gauge, code 55, and this is part number SLE, E means electrofrog, 399F, F for fine scale. So that reflects the fact that it's code 55. And every one of these has a little sticker on. It says this turnout requires 2 single pole changeover switches not included. We'll come on to that in a moment. So if we take it out, it's essentially 2 points squashed together. One turning left and the other right. And so it's got 2 throw bars and somewhat truncated switch blades. So for the first throw bar, the switch blades only extend from here to here. The second throw bar switches the route, assuming you've carried on straight through the first one. So if the first one's set to turning out, you'll turn out and it doesn't matter what position the second throw bar's in. So it's essentially this point here first, and then this point here second on the straight route, and then they've just been pushed together. But it does create a bit of a complication in this area. You'll see the switch blades for the second point are also shorter. They extend from here to about here. Other than that, it's pretty much what you would expect. It's got these sort of springs that make the throw bars snap into place. Because I'm going to be using slow action point motors, I'll need to remove those. Removing this one here can be a little bit tricky because it's all a bit tied up. It's a bit tight in there. That needn't cause a problem. And it's also got these 2 frog wires. If we have a look, the first comes from this area here, And you can unwrap these, and there's even a little groove here in the webbing that you can bury them in. And the second one, here we go, it's wrapped around, but it actually comes from this area. So that translates to this frog and this frog. So it's quite handy. It's got pre-wired frogs. So you just install one point motor on this throw bar, one on this throw bar, and you wire up this this frog connection to the point motor for this throw bar. You wire up this this frog connection to the point motor for this throw bar, and then you're pretty much done. Or at least that's what I thought. But there is a difficulty. To explain to you what it is, I need to show you a normal point for N scale. So here I've got a straightforward code 55 right hand short point. Now what I've been doing with these is wiring up the frog and connecting the frog connection to the point motor for the throw bar. But that's not strictly necessary because the frog is connected to the switch blades, which are switchblades are the bits that move, the rails that move here. So when the point's in any particular position, the switchblade connects to the stock rail, which is the rails on the outside, and so that gives an electrical connection from the stock rail to the switchblade, and the switchblade is connected to the frog, so that's all okay. But the problem that arises is if you paint your track, or over time the track deteriorates and dirt builds up on it and you get deposits and so on, then you get a bad connection between the stock rail and the switchblade. And to fix that you have to get in between and clean in between there, which is never going to be easy. And so eventually over time that connection fails and can't be relied upon. So the way around that is to run a wire from the frog, and depending on the position of the point, connect the frog directly either to this stop rail or this stop rail. So when the point, for example, is in this position, you would connect the frog to the bottom stop rail. And that way it doesn't matter if there's a bad connection here, because the switchblade is being powered from the frog anyway. So that's all good. The problem with these is because of the complexity of the two frogs being on top of each other, it's necessary to isolate the frogs from the switchblades. And that's done because by putting little cuts in the tracks. There's one there and there to isolate this frog from these switchblades. And I believe there's also one there and there to isolate this frog from these switchblades. So that's fine, but it means we've got that problem if the track becomes dirty and the connection between the switchblades and the stock rails is no good. And the way around that is to separately power the the switch blades. Perhaps it's easiest to see if we look in this area. Here's the frog, here's the switch blade, here's a bit of rail just above the switch blade. It's probably got a name, but I don't know what it is. And so what we'd be looking to do is to create an electrical connection between the stop rail here and this bit of rail here. We can do that, turn it over, by cutting away a bit of the webbing, putting a little wire across. So there's several places we need to do that. One is there, just here. One is across there. Now this one here, we don't need to power anything this side of this gap, because that is the frog that's separately powered. So is it just the three places? I think it is just those three places. There, there, and there. And I think we can do all those things by cutting away at the webbing underneath and soldering some very short lengths of wire on in just the right places. But what it means is that I'm going to need to take up the three-way point that I've already installed, and that's going to be annoying because I've obviously connected wires to it and I've got heat shrink around those wires and so on, but I can disconnect them from the point motor and cut them out of the heat shrink, take up the point, turn it over and make these modifications to it. So to better understand what's going on with all the different bits of this point, I thought I'd dig out my multimeter. And as usual, I've got it here on sort of resistance or connectivity. And if I attach one wire to the frog here, first this is the frog connection for the second frog in the series, and I can then, let me see if I can find a good way of doing this, hold on. I can then touch various bits of the point and see if they are part of the frog. So I'd expect this bit here to be part of that frog, and it is. And also this rail here, but obviously there's these two gaps. So at that point, that's not part of the second frog, and nor's that. So that's quite easy to understand, that second frog. The one that's a bit more confusing is the first frog. So let me connect to that. So obviously these aren't connected to that first frog, but I'd expect, there we go, that is. And also these rails here, so all the way up to the end there, that's part of this frog, and obviously this rail here too. But what we need to really pick out is what's going on here. So I'll just go through them and I hope you can see which one it is. This part here, that is part of the frog. I think I'd probably expect that. And so is that part there. Obviously this rail here, but as it comes down there's a break just there. So if I touch on that rail, it's not. If I let's have a further look. This rail here, which leads off to the second frog, that is part of the first frog. That's good. This little piece here, that is also part of the first frog, and all the way down this rail. until we get to this break here, and then it's not. So obviously the rail that leads down to this switchblade, that is not connected to the first frog. The only other question, big question, is whether this part is, because that seems analogous to this part, so the bit next to it, and that is not connected to the first frog, and therefore nor is this switchblade. Now, there's one more thing that I desperately want to test, and that is whether this part here, which we know is not connected to the first frog, is that connected to this rail that leads to the switchblade from the first throw bar. If I get a good tap on that rail, and this one there, and that turns out they are connected. So if I connect something to this rail that leads to this switchblade, I'm also connecting to this piece here. So that's one piece, needs to be powered. This rail here and that switchblade, that's another piece and needs to be powered. And this is the third one here. So here's the finished result. You can see if I turn it over that I've added a link just here from the stop rail to the inside. There's another one just here, and I've left the wires on there because I might use those as the feed to the stop rails. And then there's one more just here, and I've left a tiny bit of insulation on to prevent it shorting out to the switch rail. So there's that one. It's just in here. So you see it goes underneath the switch rail. However, having said that, I believe that switch rail will always be connected to the stop rail anyway. So I don't think that would actually matter if it was shorting out. So now I just need to install it back on the layout. You see I've still got my actuators there for my point motors. I might need to drill a couple of new holes to get the wires through, and then solder it all back up again. See, I've made a bit of a mess of the cork there, removing the old copydex, but that's okay. I can tidy that up and get it stuck back down. There we go, all safely restored. Glue's still wet, but I've got it clamped down. You'll see there the actuators for the point motors are sticking through the throw bars, so that's good. There's no glue around the throw bars or the switch blades, that's an improvement. And you can see there I've got my little joins on there. There's one just here, and the other one's just there. So let the glue go off, and then I've just got to wire it up. So as you can see, that three-way point is now working perfectly. Of course it worked perfectly before I modified it, but hopefully in the future when it's buried underneath some scenery and the switch rails start to get dirty, it'll continue to work flawlessly and won't let me down.